Alright, hello everyone. Today we're going to be looking at a specific area of projectile motion relating to complementary angles and launch angles as well. So, projectile motion, we looked in the other video at some of the key things, but just to summarize, an object is launched from a starting point and can follow a parabolic path like this. Okay. Now, the launch point, so this point here, the object, let's say it's a golf ball, the golf ball has to have an initial velocity. Now, an initial horizontal and an initial vertical velocity. Now, we're going to be talking about velocity in general now. So, Vu and Vx, Vx and Vy are looking at the horizontal and vertical components, same as Ux and Uy. But if we just look at V separately, that's just talking about the resultant velocity or the overall velocity. Now, if we have different launch angles, and the launch angle refers to this angle here, okay? So that angle there, at different angles, there will be a different horizontal displacement for the projectile if the velocity is kept consistent. Okay, so we're just going to assume, I'm going to write it up here, I'm assuming that Vi, or the initial velocity, is constant. Okay, now Vi is Ux and Vx, but we're just going to call it Vi for now. Now, if Vi is constant, from 0 to 45 degrees, as we approach 45 degrees from 0 degrees, then the Sx will increase. So the horizontal distance will increase. Okay. Now it reaches a maximum at 45 degrees. So 45 degrees equals the maximum. It's achieving the maximum horizontal displacement. Okay, but as we go to 45 to 90 degrees, the horizontal displacement will start to decrease again. Okay? All right. Now this occurs because at low angles, this one here, at low angles, the projectile has a large horizontal component of velocity, but a short time in the air because it's got a small vertical velocity component. However, at high angles, it stays in the air longer, but has a smaller horizontal component. At 45 degrees, these two effects are balanced to produce the maximum range. Okay, so now we're going to talk about complementary angles. Complementary angles are angles that add to 90 degrees, such as 30 degrees and 60 degrees. And they'll have the same horizontal distance. Okay, so complementary angles have the same distance, horizontal distance. Now, any two angles that add to 90 degrees, so it could be 80 degrees and 10 degrees launch angles, they will have the same Sx, the same horizontal distance. So hopefully that makes a bit of sense. So I'll just put an example down the bottom. 30 and 60 degrees are complementary angles. So they have the same horizontal displacement because they both add to 90 degrees. Okay. All right.